Okay, today I want to talk about my hydronic heating and cooling system. It's been a long journey trying to get this thing set up. Um, and so a lot of learning curve, a lot of redoing things and a few mistakes. Because it goes back to a point when I decided to have a system where it heats my house and cools my house and all the same one system. I discovered a hydronic system with a buffer tank and a heat pump, glycol heat pump that could convert both cooling and heating through using water. And I learned a lot about how water is the most efficient way to cool and heat for transfer of energy. Now, I'm here at this stage right now where I decided to go with the Renai uh, combi boiler because it's a perfect application for what I need in the house. And after a lot of research and books and some misdirection from a person who was consulting me, there's a company called Hydro Solar in Quebec. He guided me in the wrong direction because his solution did not involve a science into it. He played on my rookiness and sent me a picture like this, a drawing like this. And it was missing, for example, it was missing the vent air separator. It was missing dirt separator to protect your unit, your heating unit. Missing service valve, all kinds of stuff. I followed his direction. It didn't have all information, for example, the direction of flow, all kind of stuff. And I learned by talking to him that he doesn't really know what he's talking about. But finally, I became an expert. So basically what I have here, what you see here is a heat pump outside that would take this is, by the way, is a book from a scientist that I found out. He's a great guy. There's a YouTube videos of him and talks about almost everything. You can see it's about 800 something page. So what I'm doing here, taking liquid out, take it to the outside to heat it or cool it and bring it back. And then a pump will send it to your house. This will be a loop in a concrete. It's a circuit by itself. If you understand electronics, you understand these circuits. Fan coil to heat and cool upstairs. You can also heat and cool through concrete, but you got to keep the temperature low. You can't have too high, too low temperature. Now, ventings, key points, very important. Why you have to have those ventings. And that was my biggest problem. I had air in the system all the time and I didn't have a vent. And, and finally, after, it's like you're sick, you go see a lot of doctors and then you never get diagnosed right. Finally, I find this guy and everything's diagnosed right. So now, so what I'm doing here is that instead of heat pump, I use Renai combi boiler to heat this in the winter time. And the Renai combi boiler would only come on when it's -4. So pretty much January, February. And majority of the time, even January, February, -4, it could be around 0, +10. So at that moment, I'll have the heat pump heat this tank through a coil. There is a copper coil inside in both of my tanks. There's a copper coil inside here. You can see this copper coil here, the inlet for the copper coil and outlet. And then my domestic hot water also has 2 coils inside. And how I heat domestic hot water, I'll get back to that in a minute if I remember. But let me talk about the system. So I'm gonna transfer this right to the heat coil. Now I can have one closed loop circuit that transfers heat through a heat coil inside to the outside, and I don't have to worry about having this connected to the inside the house. I can have this all water. Glycol is very expensive, so water is the cheapest and the best way. Water is also the best conductor, both for cooling and heating. And so to have water inside the house is good. I have some already glycol in here, so I'm gonna put as much water as I can. and probably, if ever going to be a power loss or whatever, at some point in the future, I have to make sure that there's always some power. I have to back up these critical loads onto a battery charger. If in the wintertime power goes out, my house doesn't freeze, right? So that's why one of the reasons I removed electrical, I can't back up electrical boiler that takes 75 amps. And that's what one of the misguide I was talking about. I used to have 18 kilowatt electrical boiler, and it was good, but not good enough. It couldn't do both in the coldest time, couldn't do both heating and cooling. Sorry, it couldn't do both the domestic hot water and heating the house. 18 kilowatt was about 40,000 BTU. I think maybe 54,000 BTU. And what happened was, I think my house is around 80,000 BTU, and the person who was helping me did not calculate the load of the house properly. And so that's what happened. So I learned a lot. I removed that. You can see it there. I removed it. It's a great boiler, but it would take up some. If you use electric boiler, and I'm anti fossil fuel. The reason being is mostly politics. I don't believe, the whole world has problems because of oil. So I emotionally decided to go electrical, but 75 ampere, and then I have to make sure that it's the 100 ampere because of the capacity. So it will take up a whole 100 amp, and my house has only 200 amp, and that was bad for my house because half my electric load going on the heat boiler. I have my electrical service going on my heat boiler. It's not a good idea. So I decided to go Renai combi boiler. It's the best one. I'm going to finish it up today, and I'll test it, and I'll do another video on how it went. But so, in having now, I also learned that these pumps are very critical, and having a variable pump that you can control the flow, or having a flow controller right beside it, is the best thing, because everything is about the flow, baby. Because I heard that from someone in the hydronic system. It's all about the flow. So if you don't have the correct flow, you will never have a correct load transfer onto the boiler. The buffer tank. And there's a calculation for that. So I don't have any issue right now with heating the hot water tank through the coil. But the buffer tank, it takes a little bit longer because this pump might be much bigger, which I was also led by a person in Quebec for me to purchase without doing any kind of calculation. I know based on my calculation, roughly I only need one GPM flow. This one is 16 GPM. So you can imagine the heat transfer is not quick. So if I were to describe, so just like that, it's going to take the liquid out of there. Right now it's connected there. I'm going to disconnect that. It's going to connect to here, feed it through the dirt separator. Pressure is going to be provided 12 psi, and then the pump has to be after the pressure tank, and that was not also in my design, my previous design. If I were to show you the design that was sent to me, to get me impressed, but it wasn't the right type of design. It's supposed to be after. There's many things I learned. Even if you ask ChatGPT, it will tell you the whole, when you set up a hydronic system, it tell you the correct place to place these components, right? Even every one of them. So now I have it in the right place because research and stuff like that. It goes through there, and it's supposed to come back out through the hot water outlet, and it's gonna go up here, and I need one-way valve here, and then it's gonna go back in the buffer tank. That's only for winter time. For the summertime, to cool it through this coil, the heat pump does the work. Basically, there's a three-way valve up there, right? Once you heat the domestic hot water through the coil, it turns the other way. When you want to heat the buffer tank or cool it in the summertime, it comes through here, which I have to disconnect here because that setup is just a temporary. Because it's winter right now, I have to have heat running. That's why I have this thing connected temporarily. I have to cut that off only have this go into the coil, right? And then come back out. And this is going to be cut off. Come back out and go out through this pump to feed into the heat pump outside, and it's going to come back to that three-way valve, and either going to go, and then three-way valve has two directions. One is to this buffer tank, and the other one is, depending on your demand, to the domestic hot water tank, which is 500 liters there. Now, and then they're connected in parallel, right? And so I have to have one-way valve over here also, and I have to have one-way valve somewhere here. So it only guarantees one direction, right? So now that's in a nutshell. The domestic hot water, so the code in Canada is you have to heat, and that's for a reason for bacteria grows, I was told, between below 45 Celsius to 30 something Celsius in the hot range. In the cold range, bacteria doesn't grow. But if you heat it up to 50 Celsius or 140 Fahrenheit, it will kill all the bacteria, it's guaranteed to kill all the bacteria. So for that reason, that hot water tank has to be heated to 140. And then after that, by code, it has to be reduced to 120 Fahrenheit. That's why the thermostatic temperature valve that reduces it to 120. Now, what makes a boiler popular, a regular boiler just to heat your hot water for domestic hot water, this one does both domestic hot water and it heats a house. What makes it popular is that when you don't store water, right, you don't have to heat it to 140, right? So as you're feeding it from your well, your pressure tank over there, as you're feeding it into the boiler, you can set it to whatever temperature you want because it's not going to be stored 110, 170. So you save energy in that way too. So it makes it so popular. That's why these tanks are not required, because for you to keep it at 140 constantly, heat it up to 140, cools down, heat it up to 140, cools down, maybe may be used, may not be used, need to keep it at constant temperature, you're spending a lot of energy. Whereas when only on demand, you heat it into a temperature much lower, it takes a lot of temperature to get 140 to just the right temperature that you want by code is the best way to do it. However, I also have a plan to transfer heat onto that buffer tank from the sun using thermal heat collector. So for that reason, I'm conflicted in how I'm going to use that buffer tank. Not buffer tank, the domestic hot water tank. So I haven't made my decision yet. I'm going to have to do more research. But right now, I need to have that boiler connected so it can work. So I appreciate it. I think this is one of the best videos I've probably made. I hope you guys learned. Please subscribe, hit the like button, and also the notification button. And please bring me to 1,000 views. Thank you.